programming, spreadsheet programs like Excel. We used to have several spreadsheet programs in the past, but now we are, I think, down to mainly Excel, and then Apple has an equivalent version for Macs. If you don't, of course, you can have the Microsoft Excel on your Mac, but they also have their own version. And then we'll talk a little bit about programming languages and how the flowcharts or the programming tools are used to solve some basic engineering problems using your computational tools. Okay, so that is what we'll be talking about. And unfortunately, there is not much reference to these computational tools in your reference handbook. For all other topics, there is at least some reference pages. You may come across few things here and there in the electrical engineering section, but not really related directly to what we are going to be doing. Okay, all right. With that said, let us talk about spreadsheets now. Now, I am assuming if you are an engineering graduate and has been, doing engineering, it is pretty safe, in my judgment, to assume that you all used Microsoft Excel or an equivalent spreadsheet program, and I hope you did. And that should make whatever I will be talking about very simple. Okay, even if you have not used it, still the spreadsheets concept is relatively simple. Okay, spreadsheets. Okay, just 1 second. Spreadsheets are made up of some rows and some columns. So the intersection of a row and a column would give you what we refer to as a shell. Yes, not shell, I mean cell. Pardon me. Okay, so how do we name these? We name the columns with the alphabet A, B, C, D, E, and use the numbers to denote the rows. Okay, so columns are denoted by alphabet and rows are denoted by numbers. So what would this be? That would be cell C2. That is how we would write cell location. Okay, and similarly, if I go to this would be cell E3, like that. That is how we denote the cell. Okay, now what kind of information I can put in each cell? I can put a text saying, okay, like a heading, right? So this I can put semester, right? So let's say I'm trying to compare the grades from several semesters of my class. So I can say fall semester 2017, spring 2017, fall 2016, spring 2016, like that. So that would be a semester. Or let us say I'm trying to count, let's say I'm trying to get the data for number of items sold, right? So then I may have a heading, item name, then items sold in January, February, March in each of the columns, right? So you can have a heading. So that would be item. That is the heading, right? Then I can also have data like numbers in different format. It could be time, it could be dollars, it could be quantity, whatever it is. All kinds of numerical values can be placed in there. Okay, so we can place the text like labels and headings. We can place numbers and values. And third, we can put formulas in there. Formulas like, hey, take the data in C2, multiply that with 10 and divide that by 24 and put that in column B2. Okay, all kinds of combinations are possible. Some of these formulas or functions, as we call them, they are already defined in your spreadsheet program like Excel, right? So for example, you want to calculate the log of the value in C2. So it takes the numerical value in column C2 and calculates the natural log or arithmetic log, or add up A1 through A10 and calculate the average of that. All these are formulas, some of which are already defined. They're called built-in functions, and you can use those functions, or you can write your own function called a macro, and we'll talk about them a little bit later. Okay, so you understand how to report or how to denote a cell, and then you also know what kind of information can be placed in each cell. Now, so we already talked about the cell reference, which is A6 or C2 or E3, which indicates it is in the column The first alphabet that you see is the column reference and the number is the row number. Okay. Now, when I am referring to that particular cell, I would say A6. It means, hey, get the information that is in A6. Let us say if I say A6 times 10, what it means is get the value that is in A6, multiply that with the 10 and put it wherever I wrote that formula. Now, if I copy that formula, let us say this is my column B, okay, this is column A, and let us say this is let me start with 4, 5, 6, 7, 8, right? So if I put a value, this is C, okay, let us say I put a value of 7 in here, and I wrote for B6, in column B6, I'm going to have A6 times 10. When I write that column, that formula in here, what will I end up having, guys? 7 times 10, 70, right? And this is the formula I have in the cell. Remember, cell will only show the result of the formula. Okay. Now, let us say I copy this and paste it here. What would happen, guys, if I copy the formula that is in B6 and paste it in C6? What would happen? Okay. It would take B6 and multiply that with the 10, not A6. You all agree that it is not A6, right? Because what happens is when I copy the formula that is in B6 and paste it, it will move whatever cell reference it has, it moves. That is called relative reference. That means when I move from B to C, the A6 is changed to B6 times 10. And that is called a relative cell reference, because what is A to B is B to C. So because A is one column before, when I go to C, it takes the number one column ahead. That means B6. If you don't want this B6 times 10, which is going to be 700, then you need to write like this: $A, $6 times 10. Now, if you copy this and paste it anywhere, it will always take the value that is in A6 only. It is always going to, because I am saying, hey, no matter what I do, it will always refer to A6 only. That's what that $sign indicates. The $sign is called an absolute designator. That means the moment I put a dollar in front of the column, that makes that column absolute. If I put the $sign in front of the row number, that row number is absolute. So no matter how many times I copy and paste, that A6 would remain the same. If I do not put a $sign in front of the column or the row, then it becomes what is called relative cell reference, and as I copy, it keeps changing. As I copy and paste, it keeps changing. Okay. So now if I only have a relative, $sign in front of a column, then it is absolute column, relative row. If I only have a $sign in front of the row, but nothing in front of the column, then it is a absolute row and relative column. Okay. So the $sign in front of the row or the column or both makes those columns or rows absolute. That means no matter how many times you copy, that won't change. Okay. So let us look at an example to understand this little better. Okay. So let us see here. Here is an example. So in here, for some people, it makes it little better if they have a visual representation of these cells A, B, C, and D, let's say. Okay, so I'm going to start with 1, 2, 3, 4, and 5. I have 5 rows. Okay, so now I have the formula $A, $4 plus B, $2 plus B2, and this is placed in cell C3. That is what I have in cell C3. Now I copy what is in cell C3. Remember, this is what I have in cell C3. This is the formula I have in cell C3. Now when I copy and paste that into D5, let me change the color here. cell D5, they are asking, hey, what would happen if I were to copy and paste this into cell D5? Okay, guys, go ahead. So what would happen to the first term? What would happen to the first term when I copy the formula in C3 and put it in D5? So as you guys know, it would be $A, $4, since it cannot change. So that means this cannot be your answer. Right? Now, what would happen to the second term? Okay, remember that $2 cannot change because row is fixed. What would happen to the column, guys? So when I was in column C3, excuse me, cell C3, I am referring to the cell one row ahead and one column ahead. Now what would happen to B when I am in cell D, cell D5? So it should be one column ahead, right? So it would be C$2. What about the last one, guys? Both will change now. Okay, so based on my second place, this and this are kind of gone. Okay, so that leaves me A, but let us look at it anyhow, right? So when I am in cell C3, I am referring to a cell that is one column ahead, because when I am in C, I am referring to B. So this would be, when I am in D, I will be referring to C. Now when I am in row 3, I am referring to one row ahead, B2, right? So when I am in D5, I would be referring to a cell that is one column ahead and one row ahead, that would be C4. So it is a relative position, relative to where the formula was. That is what is important. Okay? All right. So you don't need to draw the spreadsheet, but for some folks, having that spreadsheet helps. So whichever way it helps you guys, if you are quick and you don't need any of this, that is a good thing. So you go ahead and solve. But I would be showing you this just to explain to others that may need some visuals to understand. Okay, so let us look at one more example here. Okay, so again you would need, okay, this is A, B and C. Okay, I'm going to start with 4, 5, 6, 7, 8. So I'm starting with column 4. Actually row 4, because I don't need. So now they are saying that they put a 6 in cell A4. Then they wrote A5 is equal to the data in A4 relative and then absolute A4. Now tell me guys, what would be the value that is going to be in A5 using this? So A4 plus A4, nothing would change, so that would be 12. Right? So A4 is 6, so 6 plus 6 would be 12, not 8, right? So that would be in C5, excuse me, A5. Now they copied this and pasted onto A6. Now when I copy onto A6, what would happen, guys? When I copy onto A6, A4 would become what? Now the first term would become A5 and the second term would become, what about the second term? It would still remain the same. It would still be the same. So what will I have now? 12 plus 6, 18. Now let me go to A7. When I go to A7, A5 would now become A6 plus $A, $4. So it would be 18 plus 6, that would be 24. Okay? Any questions here, guys? Okay? Right, so these are all the basic spreadsheet functions. Now, the Excel spreadsheet or other spreadsheet programs that are marketed, they have plenty of algebraic, statistical, and lots of other functions developed and added on to your software like Excel. So these are called built-in functions. Okay, so for example, when you say A plus B, it knows that you want it to calculate add A1 to A2, for example. Or if I say sum C1 through C10, it knows that it needs to take all the numbers in the cells C1, C2, C3, etc. up to C10 and add them up. Or if I say average, then it knows that it needs to sum up the numbers between C1 and C10 and divide it by 10. So these are called built-in functions. It also knows things like natural log, exponential, all those kinds of things. Log of A1. Okay, so it takes the value in A1 and takes a natural log or a arithmetic log of B12. Okay, or exponent, or a bunch of other things, because there are thousands of them, so I cannot obviously list all of them. So these are called built-in functions, which are already defined for you by your software. Now, these softwares also gives you the ability to write your own function. Okay, you can use combination of functions that you already developed and then create your own, a bigger function, and keep using that again and again. When will you develop a new function? When you know something that you are going to use it again and again. It's a good idea, obviously, to develop your own macro. It's called a macro. So this is supposed to be R macros. Okay, so you write your own macro, you save it, and then you use it like the way built-in functions work. But in this case, this is your own function. So these are called user-defined functions, are also called macros. Okay, in our basic class, obviously, we don't go to the extent of developing macros, but that is the purpose of that. Okay, so that's all I have about the spreadsheets. Now we will go about computing languages. Okay, now machines like our computers, your iPhone, your Dell computer, or your HP computer, or your Mac, can only understand what is called a machine language. Unfortunately, not everybody can understand a machine language. People like you and me are clueless what a machine language is. So for us to be able to use these functions, like these whatever the language, machine language, either we know, or we learn and we train and then write code in machine language, or somebody will have to write a translator that would take what I want to tell the computer and convert that into a language that the machine can understand. So for example, if I want to talk to somebody in Japanese, I don't know Japanese, so I will speak in the language that I know to a translator, and the translator would translate that to Japanese so that the other person who speaks Japanese can understand, right? Similarly, we need, so if you have a machine language, ML, and you have another language like Fortran, machine cannot understand the Fortran language. So you need a translator, which we call it as a compiler. So you feed the Fortran language to the compiler, and the compiler would check your Fortran program, and then if everything is correct, would convert that into a machine language. You might have heard .exe file. Anybody heard? Because when I was going to school, we used to run what is called MS-DOS, disk operating system, and you have to have a exe file. So exe files are really the machine language files. Okay, so what this compiler does is it checks the code you have written in the language you have written and converts that into a machine language. Obviously, the compilers are different for different programming languages. If you are using a Fortran, you need a compiler that converts the Fortran program to my machine language. If you are using a Java, you need a Java compiler. Okay, so the Java and the C++, those are more advanced programming languages than even our Fortran. Okay, because they introduce the concept of object-oriented programming. Object-oriented programming. Fortran is called a procedure-oriented programming. Okay, it's also called structured programming. So all Java, C++, Pascal, Fortran, all these are called structured programming languages. However, the newer languages like Java, like C++, they can do both structured programming as well as object-oriented programming. Okay, so as we moved away from machine language, in the beginning they used what is called a assembly language, which is a very primitive language, very close to that of a machine language, and still you needed a lot of expertise. But as we got better, we got into the so-called high-level languages like C, C++, Fortran, etc. These are all called high-level languages. These are more user-friendly because they look more like English rather than zeros and ones, which is what is a machine language. Okay, so then all these programming languages would need a compiler to convert the code you wrote in C, C++, or Fortran into a machine language. Okay, so before we go into programming language fundamentals, people take any task. Let us say you're supposed to solve a problem, right? So how do we engineers solve the problem? First, we write down the steps. Okay, so first calculate A value, then substitute the A value and estimate the C value. Like that, we follow the steps. So these kinds of logical steps that we follow to solve a problem in programming is called an algorithm. So this algorithm is nothing but series of steps that we use to solve a problem. Okay, that is called an algorithm. Now, algorithm can be written in English, which is called pseudocode, meaning you write all the steps in just plain English. That is not a programming language. It is just plain English. Now, once you write the plain English procedure, then you will go and write the actual code, because remember, the code would have to follow certain, just like English language has grammar, each of the programming languages has their own syntax. They call it syntax. So basically, every statement has to be written in a particular way. That is called syntax, right? So first you write the pseudocode, which is nothing but a English statements, which you would later convert into a programming language, or use flowcharts. Again, you convert the flowchart later into a code, programming language code. Okay, so you can do any one of those. Okay, some people write pseudocode, English language statements, or some people use flowcharts. Okay, most of the examples that we are going to be studying in this next 1 hour or so, these are nothing but pseudocode, because they are not exact programming language code. Okay, because each language uses a slightly different syntax. So to make it easy for us, most of the computational tools that we are going to be studying about, we are going to use the pseudocode. Okay, and so the problems you come across may not be very specific to one programming language. So those are mostly generic. So if you know how to write English, you should be able to write whatever they are asking you for. Or most of the time, they give you a small piece of the code and ask you, hey, what would you get if you do this? Okay. Now, the flowchart, as I mentioned, is a graphical representation of the algorithm. So you can see how programming logic would go through. Okay. So these are some of the symbols. So a terminal, a oval-shaped thing, is used to start or stop a process. Okay. If you see a diamond symbol, that means usually it is a decision. Is it true? If it is yes, do this. If it is no, do something else. So is y greater than x, right? That kind of stuff would go into the symbol. And if you have input and output, you use this box to indicate you are giving an input or you are expecting an output to come out. Okay. Similarly, a connector. So if you are, continuing the flowchart somewhere else, you use the connector to indicate that you are connecting it to something else. And now processing is, and also this predefined process, here you will have the code that actually does some calculation. Okay, so you may say, hey, pick up the data from the input and multiply with 10 or whatever it is. Complex calculations you will write in the processing, or you may have a predefined process. In Fortran, we call it a subroutine. This is in Fortran. And in C or C++, we call the same thing a function. So if it is something you're going to use again and again, you predefine that, and each time you need to do something, you call that predefined subroutine or predefined function. Okay? And if you ever have to write comments, you write them like that as an annotation. Okay? And if you're going to another page, you use that symbol to indicate the rest of the programming is given in the next page. Okay? So these are some of the symbols. So as we go through, you would see that we will be using some of these in the examples as well as in the workshop as well, in the refresher as well as in the workshop. Okay. So now let us understand what a structured programming is. Okay. The structured programming is procedure-oriented programming. Okay. The structured programming is procedure oriented, meaning it places a lot of emphasis on following steps, step 1, step 2, step 3, and you must adhere to that procedure. That is the key for a structured programming. Remember, I also told you a object-oriented programming. Object-oriented programming. That is, it is most of this, the introduction of this object-oriented programming is what took us from the early 90s or late 80s, early 90s to where we are today. The explosion of these softwares, tools, these internet applications, all these is a direct result of this object-oriented programming, because procedure-oriented programming is a lot more involved. So that kind of stuff is still limited to mostly high-level computing like engineering computing. Okay, but object-oriented programming really helped us to go way beyond what anybody expected in late 80s, early 90s when those programs were developed. Okay, so what is the big deal about this structured programming, right? Structured programming languages, C, C++, Fortran, Java, all these have structured programming. However, this object-oriented programming is mainly in C++, Java, etc. Okay, remember, C++ and Java, they can do just structured programming also, but they are a lot more versatile languages than your typical Fortran. But remember, for a lot of engineering, we still use Fortran because Fortran has certain advantages when you are doing high-level computing. Okay, so there are some tools. Okay, here are some of the tools that are available for us to use. Again, in each programming language, how we write these statements will be different. But for our learning right here, we will be using the so-called pseudocode. So it doesn't really matter how the actual programming language would write that statement. We just need to write a English language-like statement or pseudocode. What are some of the tools? If X is greater than Y, then do something. Or let me say, then X equal to 5 times Y. Okay, else move on with the program. Meaning, if this statement is true, do this and then go with the rest of the program. If this statement is false, then don't do this statement but move on with the rest of the program. So what is the difference between being a false and true, guys? Only one difference. If it is true, this statement will be executed. If it is false, that statement will not be executed. That is the only difference. Okay, now if I take the if X is greater than Y, then X equal to 5 times Y, else Y equal to 10 times X, then you go through the rest of the program. Okay, so now I want you to see the difference between if then and if then else. See, in both cases, these statements will be executed. In both cases, these statements will be executed. Okay, what is the difference between the if then else and if then? That is, if it is true, this statement will be executed. If it is false, only this statement will be executed, and then the following statements. Whereas for a if then statement, there is only one alternative, that is, do something when it is true. If it is not true, move on with the rest of the program. So in other words, for a if then else, I have two choices. I will follow the first choice when it is true. I'll follow the second choice when it is false. Whereas for if then, there is only one choice, and that is the one I do when it is true. Okay, so that is the if then and if then else. Obviously, if then and if then else, those are English language like statements. In how I write that in C or Fortran would be a little different. Okay, next we have do statements. Okay, again, they both are very similar, just a little different in the way they are written. Okay, do while some condition is true. Do while I is greater than or equal to 15, then you will have a bunch of statements, and then you would say end while. That means as long as I is greater than or equal to 15, I keep repeating these steps. And remember, at some point, I need to keep increasing or decreasing my I statement. Otherwise, I will be in a infinite loop. If I value is not changing, that statement would keep remaining true, and thus I will never get out of the loop. So at some point the I value must change, so that this condition would become false at some point. Okay, do until end until is exactly the same, so I won't repeat it. And then for loops, again it is a loop, so you may say for I value less than or equal to 100, then you may have a bunch of statements, and then somewhere I value must be changing. Okay, so you keep repeating this as long as I value is less than or equal to 100. Okay, and a go to statement is simply you say go to line 25. So you are in line 5 and you say if condition is true, go to line 25. So it skips all the lines between 5 and 25, it simply jumps to line 25. So this is a lot of people do not like this because it is against the structured programming concept, which means everybody that is looking at your program must be able to follow the procedure and make sure that there are no errors, which is called debugging. Finding the errors and fixing is called debugging. Okay, so people don't like it, but if you have to use, you can use them, but it is not a favored statement, and you will see some examples. Okay, so these are the tools, guys, and that's it. So what we are going to do next for the next 20-25 minutes is understand and look at some of these tools. Now, if I am writing a statement like this, what does that mean? Is that correct? Can I write something like that? Okay. In mathematics, obviously this cannot be true in mathematics, but we are not in a mathematics class today. We are in computing programming or computer programming class. So what does that mean? In a computer programming, this sign is called assignment operator. It is called assignment operator, which means it calculates what is on the right hand side and assigns that value to what is on the left hand side. So in other words, on the left hand side, I will have the variable name. A is a variable name, or AB is a variable name, right? Variable name. And then on the right hand side, you can have a simple variable like that. So that means value of B is assigned to A, or I can say B times 5. The product of B and 5 is assigned to A. So the equal to sign in computer programming languages means what is on the right hand side is assigned to what is on the left hand side. So you may say, hey, if A value is 10, 10 plus 5 is 15. So now you are putting 15 to A. Exactly. So after this step, you can have any calculation you want on the right hand side. However, on the left hand side, you can only have a variable name. You cannot have any calculation. For example, you cannot have A plus B is equal to B star 5. No, you cannot have that. Why? Because this is a formula. No, you can have A, you can have a variable AB, or you can have a variable called VAR, but you cannot have any calculation on the left hand side. All right? Any questions here, guys? Okay, I believe I left something somewhere. We need to know examples of each for the exam. So we'll be looking at some examples here. There is nothing on the screen. Should we try to remember the symbols? I don't think you need to remember, but if it is given, you need to be able to follow through. Okay. And somebody says symbols are in the reference manual, page 227. Okay, please do look at them. Okay. So now here are some simple calculations, plus, minus, multiplication, division, exponent, all that kind of stuff. You guys are already familiar. And just like the way we do in math, we follow this sequence: exponential first, then we use the multiplication and division in the order they appear. Then we go to plus and minus again in the order that they appear. And the exponent is written like this or like this. Okay. So with that, now let us start looking at some examples, I believe. Okay. All right. So this is a flow chart, guys. Okay. Somebody asked, do you need to remember the symbols? Just enough to see. When you see something like this, you need to be able to recognize what they are saying. Okay. That's all. I don't think they would be asking you to make a flow chart. They will be giving you a flow chart and ask you to calculate what would happen. Okay. So here, these are called initial, setting the initial values for the variables. So whenever you see something like that, they are telling you, hey, give one box for X and set another box for T. And also they're saying, put a value of 2 in the box for X and put a value of 3 in the box for T. So next time I want to check what is in X, I just go to X and pick that up. So 2. Now they're saying X equal to T plus 1. What would happen now, guys? First I calculate what is on the right hand side. What is on the right hand side now? T plus 1. So that would be 3 plus 1, 4, and that 4 would be placed in the box for X now. Okay. Now go to the next statement. Now what is on the right hand side? X plus 1. What is the X plus 1 value now, guys? What is the value of X plus 1? Now remember, there is no more 2 in the box for X. So whenever you refer to X now, you will pick up that 4. So 4 plus 1, now T will have 5 in its box. Is T greater than X? Guys, is T greater than X? If it is yes, you come out. If it is no, you go back and repeat this with the values of T and X as they are. So again, here is a tip. If you are solving it, it is always a good idea to keep track by writing something like this. So keep writing every time you replace the value right next to it, so you are keeping track. So what is the value of X when you got out of this? 4. Okay. So that's all there is, guys. Most of these are pretty straightforward. Okay. So here is another example. Okay. So this is too simple, so I won't take too much time here. So it is just like a math. So first you calculate what is in the parenthesis, then apply the division. So it would be 12. So it's almost like a math problem there. Okay. So let's keep going. So here I already gave you examples of how we write the if then and also if then else. Okay. If then only have one action which is executed when the statement is true, whereas if then else has one action when it is true and another action when it is false. Okay. So with that said, again, one disadvantage of your pseudocode is the way they write. They write it like English, right? It is not a proper syntax. So sometimes it is a little bit confusing, but for whatever it is worth, we'll go through it and then hopefully you will get comfortable. Again, I'm going to create a box for X and a box for T. What am I going to put in the box for X and T? A 2 for X and a 3 for T. Now, what does this say? If X times 2 is greater than T. What is X times 2, guys? X times 2 is 2 times 2, 4. If 4 is greater than T, which is 3, yes, the statement is true. That means I execute this. What would be the value of T now? If I execute T equal to X times 2. Okay, it would be 4, Ruben. Okay, because X value is still 2. Right, Ruben? Okay, so it is 2 times 2, 4. Now, once I complete it, so this is executed only when this condition is true. So I move on to the next line, which is if T is greater than X. Is T greater than X, folks? Is T, which is 4, greater than X, which is 2? If it is true, then execute this. What would happen to X value now? T times 2. That would be 8. Okay, now I executed this because the condition is true. Now I am moving on to the next line. And that says if T, which is 4, less than X, which is 8, then X equal to T plus 3. What is t value, guys? 4 plus 3, that would be 7. So when I get out of this, I have a value of 7 for my x. Okay? All right, let's keep rolling. We have to keep going to finish all the material we have. So here is that example. We looked at the solution already. So now that go to statement, as I said, simply if I say go to 25, that means it will look for line number 25, it jumps there. That's why people don't like it, because you can arbitrarily write this go to statement and then mess up the whole program. So that's why people do not like it, but under circumstances, certain circumstances, go to statement can be a very useful tool. Okay, so here is an example of a go to statement. Okay, again you start off with a box for x and a box for t. Okay, t has a value of 8, x has a value of 4. Now this one, even though it looks like 1t, that is your line number, that is your row number, or whatever they are denoting that this is your line 1. So in line 1 you have t equal to t minus 1. When I execute that, what will I get, guys? I take t value, subtract 1 and I assign that to the new t. X would be x plus 1, so it would become 5. Then if x is less than t, 5 is less than t, then go back to line 1 and execute t equal to t minus 1, x equal to x plus 1. Then check again. If x is less than 7, excuse me, if x is less than t, which is 6 less than t, no, so you get out. When you get out, you have a x value of 6. Right? Any questions here, folks? So please mark your attendance so that they can take it off. Okay. All right. Let's go to the next example. Okay. Here is the solution, which I already explained. So let's go to the next one, which is a do while or do until. Both loops work exactly the same way. Do while and do until. It is just a different way of writing. And I already showed you how the condition, how the do while statement is written. Do while some condition is true, bunch of statements, then end while. Okay, so you can have just one statement inside the do loop, or you can have 5 million lines of code between the do while and the end while. Okay, so how many lines you have is just a function of what kind of program you are writing. Okay, here I just have 2 lines here. While t is greater than or equal to x, I have 2 statements, t equal to t minus 2, x equal to x plus 2. But only thing I need to make sure is whenever I put a condition in the do while, that condition must become false at some point. Otherwise, I will be in an infinite loop. That is the biggest problem when we are in a loop. So the first check programmers would do is, am I in an infinite loop? So make sure of that first. Okay. So again, I start with a box for x and a box for t. 4 and 8. Do while t is greater than or equal to x. Is t greater than or equal to x, guys, when I am entering the loop? Is t greater than or equal to x? If it is true, then I go into the loop. If it is false, I don't even go into the loop. Okay, yes, t is 8 greater than x, which is 4. Okay, now t equal to t minus 2, x equal to x plus 2. Now I keep repeating this until this condition becomes false. Since I checked once, now I go back and check again. Is t greater than or equal to x? Guys, is t greater than or equal to x? T is 6, x is 6. So s. Since it is s, t equal to t minus 2, x equal to x plus 2. Now, check again. Is t greater than or equal to x? T is 4, x is 8. So no. So by the time I get out of the loop, so because the condition is false, you do the end while. So you end the while loop and you get out. When you are getting out, you have a value of 8 for x and a value of 4 for t. Right? Right? Let's keep going. So the solution is written here. Now, as I told you, do until works exactly like do while. It's just a different way of writing. And I also gave you the example for for loop. For loop works similar to do, except typically here we will have a counter. for I less than or equal to 100, then write bunch of things. Somewhere that I value must be changing, I plus 5. At some point this I must be more than 100, so you will have all these inside the for loop. Again, you can have just one line, or you can have 5 million lines after the for loop. Okay, so let us take a look at some example for loop now. Okay, so here we have, again, so I hope you get my point by now. By keep writing these boxes for X and Y, this is a good way for you to keep track of things. Okay, put a box. Okay, so now, unlike earlier, now for loop is starting, they're saying t is equal to -1. So the initial value for t is -1, and then the t value is going from -1 to 2. That means -1, 0, +1, +2, because when they say the next t, that's what it means. -1 + 1 equal to 0, 0 + 1 equal to 1, 1 + 1 equal to 2. So t value would be going from -1, 0, 1, and 2. That's what that means. While that is going on, x equal to x plus t, and then increase the t value to the next value. Okay. Now, so I started off with t equal to -1. Now it says x equal to x plus t. What would be the new x value, guys? X equal to x plus t. The current value of x is 0 plus -1. So it would be, x value would be -1. Now go to next t. That means next t value would be 0. X equal to x plus t. That means -1 plus 0, that is still -1. Okay, go to next t, which is +1. Now x equal to x plus t, -1 plus 1. What would it be now? -1 plus 1 would be 0. Now go to next t, which is 2. Okay, x equal to x plus t, 0 plus 2. Now I already came to the end of t value, so I get out of the loop with a value for x as 2. Value for x as 2. All right. Any questions here, guys? Okay. So let us go to the next one then. Here, data arrays. So here it is a way of feeding the data into a program. So here they are giving you an example of, this is the data that they want to pass to the program, right? So it says read a value from the input file and set equal to the x equal to that value. So typically, if I'm saying, I may say read x comma y comma z, then I will give input. Again, this is a English, okay? This is not the real program. Input 20, 30, 40, which means x will get 20, y will get 30, z will get 40. So that is a reading. And then you may say write or print. So that means print the value of x, y, and z. It will print 20, 30, 40. Okay, like that. Okay, so in this example, what they are saying is they are reading only one value at a given time. So let us start that again. So I need 3 boxes here. A box for I, a box for y, and a box for x. Okay, I, initial value for I is 1, for y it is 0. Now while I is less than or equal to 3, is I less than or equal to 3 right now? Guys, I is 1, so it is less than or equal to 3. Read the value from the file, because these are the data that is given in a file. So when I am reading the first value, I will take -3 and set that equal to x. So my initial value for x is -3. Now, if x is less than 0, is x less than 0, guys? If it is yes, then go to line 1, where I equal to I plus 1. Okay, so I go back to while again. I equal to 2 now. Is 2 less than or equal to 3? Yes. So read the second value, assign that to x now. Okay. Now, if x is less than 0, go to 1. Is x less than 0? Guys, is x less than 0? No. So I go to else. Else, y is equal to y plus x times x. Y value is 0 plus 5 times 5. So now it would have 25. Now I equal to I plus 1, which is 3. Okay, so go back. Is I less than or equal to 3? Yes. So read the third value, which is 2, and assign that to x. Is x less than 0? No. So you go to the else, and now 25 plus 2 times 2, that would be 29. Now I equal to I plus 1, which is 4. Now check again. Is I less than or equal to 3? No. So end while. Now calculate z is equal to y divided by I, that is 29 divided by 4. What will I get, guys? Right? So that is how we would look at these problems. Okay? Any questions, guys? Okay? So one thing is, okay, I haven't mentioned anything about the so-called subroutines or functions, because subroutines are part of a Fortran program and functions are part of a C program. All these things do is, let us say you are going to calculate something again and again, right? In that case, you define this subroutine or a function and leave it. You define this in the beginning of your program, and then you keep calling that subroutine or the function every time you need to make that specialized calculation. So that is the concept of that subroutine or function. There is some similarity between the two, and there is some difference between the two. Okay, it is my general understanding that they will not go into very specifics about a given programming language, because they understand that that you may not know the exact language, because different universities offer different programming languages. For example, in my university, we teach C++, and I taught for a few semesters C++. So when I went, we learned Fortran, and some schools still teach Fortran. So, but somebody mentioned in the workshop, I have a couple of things here and there. So do not get alarmed. So if you have a background in programming, any programming language, you should be able to solve most of these problems. Okay. Now, is this a time for you to go back and learn a new programming language if you don't know already? I don't know. That learning a new programming language now may not be a wise idea unless you have a lot of time on your hand. So if that is the case, then you try to learn this pseudo language or pseudo code as much as you can, and try to solve as many problems as you can, and spend your time somewhere else. Okay, that's the only advice I can give if you don't have any exposure to programming languages already. Okay, the question didn't say which value is the first value in the array. Okay, I believe they gave you the order of those, so that is the, okay, unless you want to put them in some other order that you prefer. This is the order they gave, so I have no reason to believe any other order. All right, Amin? Okay, can you go back and explain the -5, please? I'm not sure where we are with -5 now, because I don't believe we had ever -5. We had -3 in the beginning, then we went to 5. All right. So here is what we are going to talk now, guys. So here I put some computer terminology which used to be part of FE exam before the CBT format came in. But after the CBT came in, it is not explicitly mentioned in your specifications for your FE exam, which is for civil engineering folks. It is on page 200 and, let me see, 261. Okay, so there they did not specify if you need to be familiar with the computer terminology. Okay, so just to be on safe side, I still left some of these terminology, and I left some problems in the workshop as well, which I would strongly suggest you be familiar. It only takes 15 minutes probably, so read those, not now, but at your leisure time. There is nothing much for me to explain here, so there are a few terms here and there, so be familiar with them and get comfortable, and look at those workshop problems when you have some time. Okay, so with that said, that concludes my refresher notes, And now we are going to get into workshop problems. Here is what we are going to do now. Okay, I'm not sure how much time I can give because we don't know how long you guys need to solve these. And I have about 30 problems, 24 problems, 20 problems that I would like to get to, if at all we can. The remaining 7 problems are for you guys to be looking at a later time. So out of the 20, my goal would be to solve as many of them as possible. So I will give you guys about 30 minutes to take a break, short break, maybe a couple of minutes break, and then solve as many workshop problems as you can. If you can solve all of them, that would be great, because some of them are pretty straightforward. Some of them may take a little bit longer. Okay, if you can solve, don't get stuck on one problem. If you're taking too long, just read the problem and go. Because by the time I come back to review the problems, I want all of you to be familiar with the problem itself. Even if you did not finish the solution, but be familiar with the problem, so that when I start talking about the solution, you can follow along quickly. Okay, so please take some time now, solve as many workshop problems as you can. If you can solve all of them, that would be the best case scenario, and then we'll start reviewing them from 8 p.m. Central. And I hope that 1 hour we can solve all the problems. Okay, if not, at least you will have all the solutions. We need it to remember, or just for our, yeah, that is too basic. Once you look at it, it's not something you have to make an effort to remember. But those are very basic computer terminology. You guys should be fine. Okay, see you guys in a bit. Workshop problems. You should have received a note with about with workshop problems. It would look something like this. Yes. Okay, see you guys.